There is a kind of planet that has no star, no sun to orbit, no light to reflect. It moves through the galaxy in total darkness. A frozen world that hasn't felt warmth in billions of years. These are rogue planets, and there are more of them than there are stars. Right now, the nearest one we know of is 20 light years away, but we've only detected a handful. The rest, billions of them, are out there, invisible, moving, and some of them could already be on a trajectory through our region of space. By the end of this video, you'll understand what happens when a rogue planet enters a solar system and why we might not see it until it's already here. A rogue planet begins its life like any other, orbiting a star, held by gravity, part of a solar system, and then something shifts. Most often, it's another planet, a larger world, a gas giant, whose orbit brings it just a little too close. Gravity turns chaotic. One planet pulls, the other resists. For years, sometimes centuries, and eventually, one of them loses. The smaller planet is flung outward, not destroyed, not consumed, ejected. Its velocity climbs. Beyond escape velocity, it breaks free from its star and crosses the boundary of its system forever. At first, it may still be warm, residual heat from its formation, but space is cold, 2.7 Kelvin, just above absolute zero. Within a million years, its surface freezes solid. Any atmosphere, if it had one, either condenses into frozen layers or slowly escapes into the void. Any oceans become ice. Not surface frost, ice, kilometers deep. The planet becomes a frozen tomb, still spinning, still moving, but now without a star. It drifts through the galaxy for billions of years. And this is not rare. Simulations suggest that for every solar system that forms, at least one planet is thrown out, sometimes more, which means there are billions of these worlds cast into the dark, moving through space at tens of thousands of kilometers per hour. They don't orbit, they don't slow down, they just keep moving. If a rogue planet doesn't emit light and doesn't reflect light, how do we find it? The answer is gravity. When a massive object passes between us and a distant star, its gravity bends the light. This is called gravitational microlensing. For a brief moment, sometimes only hours, the star appears brighter. Then it returns to normal. That brief brightening is how we know something invisible passed in front of it. In 2011, astronomers confirmed the first rogue planet using this method. Roughly the mass of Jupiter. Alone, no star within light years. Since then, we've confirmed only a handful, perhaps a dozen. Current models suggest there could be up to 2 trillion rogue planets in the Milky Way alone, more than stars. And we've confirmed barely a dozen. The nearest confirmed rogue planet is about 20 light years away, but that doesn't mean there isn't one closer. It only means it hasn't revealed itself. Because the only way we'd know a rogue planet was nearby is if it crossed in front of the right star at the right moment while we were looking, or if it entered our solar system, and by then it wouldn't be a discovery, it would be an intrusion. What happens when a rogue planet enters a solar system? It depends on where it enters and how fast it's moving. If it approaches from beyond Neptune, it might pass through with limited immediate disruption. Outer orbits would shift slowly. Change is measured over centuries, but if it moves inward, if it crosses into the inner solar system, everything changes. A rogue planet with the mass of Jupiter, passing near the region between Mars and Earth, would exert gravitational forces strong enough to disturb every orbit around it. The asteroid belt would respond first. Objects stable for billions of years would be nudged into new trajectories. Some pushed outward, others redirected inward. Earth's orbit would not snap instantly, but it would drift. The distance from the sun could gradually change. Axial stability could weaken. Seasons would fluctuate. The rogue planet would not need to collide. Its gravity alone would be enough. We would measure the shift, calculate the drift, and slowly realize that the architecture of our solar system was changing. The question I asked at the beginning, whether we'd see it coming. Now you know the answer. We wouldn't. Not because we're careless, not because we're unprepared, but because some objects do not need light to change everything. A rogue planet doesn't announce itself. It doesn't shine. It doesn't warm. It doesn't send a warning. And there is no contingency plan for a wandering world, no evacuation protocol, no planetary shield, no way to redirect something with the mass of a planet, not in hours, not in days, but in years. Slow enough to understand, too large to undo. And here is what makes this different. The rogue planet wouldn't know. It isn't hostile. It isn't intentional. It has been drifting for billions of years, following the same gravity that governs everything else. It would not end a world out of malice, only momentum. Those are events. This is a world, an entire planet, older than Earth, colder than the space between stars, still traveling, still silent, still capable of altering everything, simply because it crossed our path. You are alive in a universe where planets wander, and the only reason you are still here is that none of them have wandered close enough yet.